It's time for Myth of the Week.
Alright, we have a great myth for you this week. So this started, one of the guys on the jobs called me and they're like, hey, do we have to scrape the paint off to put this ground bar in? And I'm like, no. I was like, as long as you're threading it in there. And they're like, well, one of the guys said we have to scrape it off every time. I'm like, nope. I was like, that's a myth. And so then I was like, alright, myth of the week is going to be a true statement. So non-conductive coatings such as paint, lacquer, and enamel on equipment to be grounded is not required to be removed if the metal is tapped with machine threads maintaining 2 threads of contact. That reference is 250.8, saying that that is an approved method and you're able to do that. I don't know where 250.12 came into this, where it says that you must remove paint and varnish unless otherwise unnecessary. But this would be one of those things where it is unnecessary. And so I really like this myth. I thought it was really funny. A lot of the guys say that you always have to remove the paint, and a lot of guys say, well, just just do it just so the inspector can see it. Well, the inspector can't fail you if it's not a code violation. So this one was a really favorite one of mine. This right here is a perfectly code compliant picture. In here, there's no paint removed. You use the screws that hold the ground bar. Your grounded conductors and your grounding conductors are tied to the same bar, which is perfectly code compliant. As long as that's a service entrance, first means of disconnect, or some way that is going to be not 250.6 violation. And so I really appreciate James jumping in on this myth. Like I say, this one has been argued a lot out there, and I think the biggest problem is a lot of the inspectors just read 250.12 and just think that the paint always has to be scraped. I'm not going to mention names, but there was some people out there that said the paint always has to be scraped. That is 100% incorrect, and so this myth is, this actual statement that I have up on the board is a true statement, so that would bust the myth that you always have to scrape the paint. But I'll let you expand on that, James.
Okay, I want to go back on something else real quick before, because I'm going to tie something in that was previously with this right here. Okay. Mm-hmm. Now, one of the things that I've been arguing with them on the groups, it's always the same guy, those ECD boys, but they said that the NEC overrides the manufacturer's instructions. There's testing procedures that are put together, and of course, Jeffrey Bauer, he lied and misquoted what you said. He made the statement that you said that the code is nothing but a companion standard. And
well, I said supporting document.
Yeah, well, same thing, companion. And that is not exactly what was said. When you look at the testing procedures that are used for the different types of equipment, they create those, and those become an ANSI and an ASTM standard. Okay? Sure. And when they do that, they even state in there that they take into consideration the national codes. That can be the National Electrical Code, the Canadian Code, whatever. They have to take those into consideration. So if I was looking at this illustration right here, they didn't remove the paint, and they take and secured that with machine threads that made at least 2 threads of contact. Would that be in compliance with the standard in the NEC?
Well, I'm going to take that a step further and say that if I'm that UL evaluation body, I'm going to say that metal of that enclosure is going to have a thickness that's going to allow for 2 threads engagement, so I don't have to second guess myself. I don't have to inspect it. I just know that when I see that UL sticker on the right side there, I know that thickness of that metal will ensure 2 threads of contact on that tap thread.
And that's interesting that you brought, because I was going to say that. That's actually in the code, the thickness of the metal.
Yep.
Now,
Sure is.
let's look at another part of this. If I'm looking at that and I've got my all my connections there, where do they get the ranges in order for them to know if they're turning an L bin in there, or making an S or a Z bin, that they got to have those clearances so far away from where they're making their connection? Would I happen to be looking at 312.6 A and B in the
Yes,
code?
sir.
Sure.
Yes, sir.
And that's what I've been saying this whole time. You know, you look at the code, there's a lot of stuff in there that gets into the, you know, you've heard me say this a million times. The code is a design and installation standard. I've always said that. And that
Not
provides,
manual. Not manual. So don't get him wrong by saying manual. Standard, not manual. It's not an installation manual. It's an installation standard.
yeah, it's an installation standard.
Because
And
like you think about if you were to go and take that enclosure and then just shrink it by 6 inches there, you'd push all those grounds into that bus bar, and you'd push that edge of that panel board enclosure to where you don't have enough bending radius to terminate to that overcurrent device.
that's right.
So
And
that's
that's
all. That's all standard that you have to have the bending radiuses for all that stuff.
Sure, and that's why that the testing procedures that they use, they have to consider the National Electrical Code, Canadian Code, whatever that they're trying to get their listing and labeling. They look at those items, and that's why I've made this argument for a long time. You just can't pick and choose when you want to take and try to apply something. And this is just a good example right here.
Just to say that, like, my whole statement was based on the UL listing, you know, so like the Canadian code would be a supporting document,
Sure.
the NEC would be a supporting document, but they wouldn't be an overriding document for anything because they're the standard that sets that's the standard you have to conform to.
Sure, I'll give you another example. Say this was hazardous. What would they consider at that point? You would be looking at the NEC. You could be looking at Canadian. You could be looking at the API 500. You could be looking at API 505. You could also take and be looking at NFPA 496, 497, 499. You see what I'm saying? Or let's just say it's a custom-made piece of equipment. What would I look at then? Well, now you got NFPA 79 plus the National Electrical Code. So say this, just this picture here, for instance, say this was custom-made. Would I need to concern myself with the NEC when I'm doing this design? Sure you would.
Sure.
And you'd also look at NFPA 79, especially if it's industrial control equipment. Okay?
So, and
I'm
I'll
giving
kind of take this.
there.
Yeah, and I'll kind of take this a little further too, James. On that is, like in this picture, none of these lugs are torqued. They don't have torque marks on them. So an AHJ can enforce that and say that he wants to enforce 114.d.
Sure.
And say that he wants to see those torque marks. You know, a lot of guys just put the torque marks on there anyway, but you know, a lot of times, like when you get into those straight blade ones, a lot of people are like, well, I don't torque them because I don't even know what the torque value would be. Well, it's 50 inch-pounds, and that's basically as tight as you could get it by hand.
Right.
You know, so that kind of stuff is not an excuse to just not follow the NEC.
That's right. And, you know, usually I don't even look at the myth till you send it over and I get it ready that night because I'm so busy with other things. But I actually was tagged on this. And so, you know.
Sorry about that. Sorry.
well, usually I'll get tagged on something. And, you know, it's one person that when my name is getting tagged 4 or 5 times, I'm like, okay, what the hell's going on?
Bill started a dumpster fire this week.
Yeah. So I went over there and I was reading what was there. And you had like Jeremy Lee, Jeff White, I think Bauer was on there. The same old guys that argue about anything that you put on there. But, well, let me rephrase that. they argue anything you and I put on there. If it's Paul or anybody else, they're not going to say nothing. So
The problem with them is that they don't argue it. What they do is they take our words, they twist them to make what we're saying wrong, and then they argue what we said as wrong when we never said that. You know what I mean? It's just, to me, it's weird because like I never said that. You know that this was the myth. You know what I mean? I'm saying this part could be busted the myth. So whenever, just a big shout out to everyone out there that follows Nat King Code the way I do, the myth of the week. You guys don't know where the myth is actually at. Like, I don't put it as this is the myth is over here, the myth is over here. I just basically, every time I see these myths, I put them out there, and they could be true, they could be confirmed, they could be busted. Like this week, it's kind of an opposite thing because I actually posted the actual code language that would say that you don't need to remove that factory paint. Well, there's all these guys out in the field that are saying you have to remove this factory paint, and so those guys are the guys I'm busting the myth on. So
sure.
that's how I've always done it. James knows. He knows how I've always done it. And
oh yeah,
they're acting surprised now after 3 years, 2 years. You know.
you know, you go in and you a myth is a myth. It don't matter if you're trying to prove it true or false.
True.
You know, it doesn't matter. And this was a good example because right here it tells you if you got non-conductive coatings, and they tell you such as what you got paint, lacquer, and enamel, and it's on equipment to be grounded or bonding, shall be removed from threads. Now, if you're going into the metal tapping it, let me help you out a little bit. There's nothing there to remove. Okay, you're making metal to metal contact at that point. But what it says in other surfaces to ensure electrical continuity. That's what I'm trying to say. And when I first heard it, you had called me right before I started answering everybody. And you asked me about it and everything. I said, well, if it makes electrical continuity, it's one of the methods accepted over in 250.8A. I said, you're good to go. I said, that's the end of discussion there. And
well, no, and I kind of wanted to get your interpretation too, because I never heard, like, to me, 250.12, technically, there a lot of that language is just to ensure continuity of raceways. Like, I don't see a whole lot in there that says anything about scraping the paint to put a lug on there. Like, a lot of people read into this stuff, and I think they're misinterpreting it.
Well, sure. And if you look a little further, it says, or shall be connected by means of fittings designed to make such removal on it. And they were, I was sitting there reading something, and they were saying, oh, well, that's not a fitting. I'm like, no kidding. Because
like fittings have to be listed.
Yeah, I was like, you're making direct metal to metal contact with it. What I couldn't understand exactly what it was they were trying to argue there. But then I said, well, let's just take a look and see what it takes you back to. So if you have main bonding jumpers and system bonding jumpers, it tells you you're permitted to provide that connection by one or more of the methods and where. 250.8. Okay. And then if you go over and look here at 92B, this is methods of bonding at service. And looky down there at number 1, bonding equipment to the grounded service conductor by what? One of the methods in 250.8A. It ain't talking about scraping any metals or anything like that. It's just telling you if I took those threads and they engage at least 2, then you have a permitted method there for bonding it in. Then if I look here at 250.102B where my bonding jumpers are, looky there, it takes me right back to 250.8. And then if I look at multiple circuit connections, the exact same thing. It tells you that you can terminate each equipment grounding conductor to what? Based on 250.8. Then if I come look at 251.48A and I'm looking at my equipment grounding conductors and attachments and boxes, it tells you that you can use one of the methods that are set here and where. 250.8. Then if I come and look at 250.88, here's all your permitted methods. And the
Sure.
one we were looking at that was in the question was 8A6, and it says exactly, word for word almost, thread forming machine screws that engage not less than 2 threads in the enclosure. And that's why they're taking you all the way back to 250.8A and all them examples I gave, because they're giving you the permission right here to do so.
And
Now,
you folks just went on a James Stallcup code loop.
that's right. And believe it or not, you'll go in